So in this video we're going to go over some special types of polygons. And the type of polygons that we're going to go over are called an equilateral polygon, an equiangular polygon, and then what are called regular polygons. And you can figure out a lot in a name, right? So let's take a quick look at the first type of polygon, and that's an equilateral polygon. Now let's take the word apart. Equi basically just means equal, doesn't it? And then lateral, it means to the side, like when you lateral like a football or a rugby ball or something. So equilateral means equal sides, right? And that's the actual formal definition. It's a polygon in which all the sides are equal in length. So let's take a quick look at this one, for example. This is a triangle, right, because it has three sides, and each of these sides are all the same length. And remember how we mark that. You just draw a little line, the same number of lines through. So one line, one line, one line means each of these are all equal in length. Now if we moved up one and go to a square is also an equilateral figure, polygon, right, because each of the sides are equal in length. Now let's move to this one here, which has 1, 2, 3, 4, 5, 6 sides. And do you remember what that's called? A six-sided figure, right? This would be an equilateral hexagon, right? Hexa meaning 6. So again, just real briefly, equilateral just means basically all equal sides, and you just do that. Okay, now let's go to the next definition, equiangular. And again, you can probably figure that one out. Equal angles. Now, not all equilateral polygons are equiangular. Let's go ahead and look at that. Now, in an equilateral triangle, each of these angles is 60 degrees, right? And that's how you indicate that these are all exactly the same, right? You just put one little slash there, just like that. But it's a semicircular slash, which is different from this one. Now for a square, again we know that each of these angles is the same because they're all perpendicular to one another, right? And this is what we do for perpendicular. So it's kind of a special case. We just do that. And again, we all just do one because we know that they're all 90 degrees. But now let's go to our equilateral hexagon. You can see that this angle is an acute angle, right? It looks like it's less than 90, so we'll just go with one mark there. But this angle is an obtuse angle. Now, so this angle is going to be measured differently than that one. So this is what you would do. You would draw 2. Okay, which means it's distinct or different from that one. By the way, there's the definition for an equiangular, a polygon in which all the angles are equal in measure. Now the cool thing about a hexagon is that these angles are all equal, so I'm just going to do that, and then the opposite angles are equal. So opposite angles, just go across, crossing the diagonals, remember what we did with those, are always equal, right? So the ones that straight across. Now let's go to a regular polygon. A regular polygon, definition, is a polygon that have both equilateral and equiangular, that are both rather equilateral and equiangular. So up here, of these three, which one of these would be a regular polygon? It would be the equilateral triangle and the square, and this one would not be a regular polygon, right? Although it is equilateral, it is not equiangular. Now let's just do a little quiz here, okay? I'm just going to give you two different figures, and let's just see what we can do with them. Okay? Now, is this a regular polygon? Well, we can see that it certainly has equiangulars. If I were to take out my compass, I would see, or my protractor rather, I would see that each one of these is 90 degrees, right? So it is equiangular. However, this length, these are the same, but these are not. So I'd have to do 2 slash marks. So this is not a regular polygon. Again, regular meaning specifically equiangular, equilateral. Now this one is 1, 2, 3, 4, 5, 6 sides as well, right? But it's drawn a little bit differently than the one we had in the other example. If I were to measure each of these sides, they would all be the same length. All right? And if I were to measure each of these angles, I try to draw it pretty closely, they're all the same angle as well. Actually, are they? Let me just do a quick check here. No, this is exactly the same as the other one, right? So I'd have to do this. So this is not a regular polygon either. I was trying to draw one that was, but it wasn't going to work. So this is not a regular polygon as well. And hopefully that made some sense to you. Okay, so again, just briefly in summary, equilateral means the polygon has all the sides that are equal in length, indicated by the same slash marks, right? Equiangular means that all the angles are the same. Again, you can indicate the ones that are similar with just the same number, right? And then a regular one is one where they're both equilateral and equiangular, and then, for example, these two are, this one's not. So I'd like you to try to draw one that is more than 4 sides and see if you can make it a regular polygon. Okay? Well, I hope this was helpful. If you have any questions, let me know.